Hello everybody. I have been playing around with the Stone TFT touchscreen displays, and they have been really fantastic to work with. There really hasn't been any issue with it other than some of the nuances with trying to get some of the hex code up to the unit itself, but that's more related to some of the challenges with the Arduino and the ESP32 that I will attempt to explain in this video here. So what I've got on the screen here is a basic Arduino code that is really for the ESP32 chip. That's how I'm programming the ESP32 chip. And I'll go through this line by line just to kind of give you an idea of how things work. And if you wanted to check out some other videos, I think there are some that are produced by either the Stone display people or some other folks that can get into some of the, the deep nuances of what I'm going to attempt to explain here. So on the screen here, I wound up putting together two unsigned character arrays. And the first one is called sensor1_send, and it is 7. It's an array of 7, and the second one is an array of 8. And basically, these are the essentially the strings or the character sets that I'm going to be sending to the TFT display. The first one is, and actually these hex codes are in a particular order, and a lot of this is in either the documentation or some other YouTube videos, and they'll probably explain them a little bit better. However, I found a couple of things that weren't explained that I'll attempt to explain here. The first 2 bytes are the TFT display. I guess it's called a serial code or something like that, and I'll show you where to get that. But by default, it is A5 and 5A for the first 2 bytes. So everything that you send to the TFT display has to start with the A5 and 5A character set. The next byte is how many bytes follow. So for example, there's going to be 4 bytes that follow this function here. So in the third set here, it shows how many bytes are to follow. So this is 5. So that means 1, 2, 3, 4, 5. And then this one is 1, 2, 3, and 4. So this first one, we've got A5 and 5A is the serial code of the device. 4 is how many bytes follow. And then this is the special register, if you want to call it that, that's going to tell us what we're going to be sending to the TFT display. So I'm going to leave out the rest of these for a little bit later in the conversation, because some of this is going to be dependent on what we're going to look at on the display screen with the Stone TFT display configurator software. The next line is I just declared 2 integers, y and z, just to put a couple of variables in there, because I wanted to show that I can send just about any kind of number that originates from, whatever it is, a temperature device. And in this case, I used a joystick actually to show different ways you can send bytes to the display. The setup is simply just initializing the serial 2, which is going to be an important command. And this is something that I haven't seen really discussed in other videos, and I kind of had to figure this out after a couple of hours of troubleshooting. But essentially, the 115200 is the baud rate, and that is the default baud rate of the TFT display. So if you want to do 9600 or anything else, I don't know that it'll work, or it'll work reliably. If you make sure that this is the baud rate of the display, that's going to be important. The display also works on the this next field is what parameters of the serial port are. So for example, 8 bits, no parity, and 1 stop bit. is what we're going to be using. So you have to use the built-in function of Arduino, which is serial_8n1. So that's how you declare that it's 8n1. And then the next two are the pins of the ESP32 chip that signify the TX and RX pins of the serial. So we've got 16 and 17, which just so happen to be the default for serial 2. And then this is probably one of the most important pieces of this function here is this number 1 at the end. And what that signifies is that we'll want to have the bit array inversed or flipped, because by default the serial port goes, there's probably better explanations out on the internet about how the serial port works, but essentially it starts high and it's basically inverse of what you think it would be. So in order for it to talk to the TFT Stone device, we need to invert that. Otherwise, you can, and you'll see this in other videos, you can purchase something called a Max 232 chip and interface with the Stone display through the Max 232 chip. However, I thought that there's got to be a way to be able to talk TTL straight to the device. So I stumbled upon this. I was actually trying to do some translating to invert the bits, and I was having some challenges with that and stumbled across the fact that, well, you can invert everything at the serial begin statement. So that (1) is going to be important if you want to interface directly to the TFT display from the ESP32. If you do not put that (1) at the end, you'll need a Max 232 board, or if you have a circuit design that has the Max 232 already in it, you will want to make sure you get rid of the (1) statement. I just put a couple of delays before and after the serial to begin statement just to give it some time to initialize. I think this is 1 second beforehand and 1 second after. That's probably way too long. You actually don't need it to be that long. It could probably be about 10 milliseconds if you want. And then the actual detail of the program here is, we'll just kind of go through this line by line. So the first line is, I'm doing an analog read of pin 32, and I've got pin 32 assigned to the Y-axis of my joystick. So I'm just going to use my joystick to go up and down and just create some random numbers from, I think the joystick goes from 0 to 4096, I believe. And then in order to make it scale from 0 to 100, I end up dividing it by 40. So I'll at least have like a 1 to a 0 to a 100-ish number. The 0, or the Z, Zulu, I'm assigning to 0, and that's because I'm going to assign different pages to Z, and I'll talk about what I mean by that in a minute. So just think of Z as being a placeholder for different pages that I'm going to create. Now, what I'm doing here in these next two statements is I need to, because I want to send the coordinates of the joystick to the TFT display, I need to put the integer into the string that I created above here in the unsigned character string here. So for example, I'm going to put sensor2 _ send. I'm going to put this position number 6 here. I'm going to put the high byte of Y, and then in 7, I'm going to put the low byte of Y. So basically it breaks it up into 2 bytes. So if you have, if the integer is like 1, 2, 3, 4, 5, the high byte will always be 0, and the low byte will be 1, 2, 3, 4, 5. Once you start getting into 85 or something like that, then the high byte will be will be the multiple of 85, and then the low byte will be the lower end of that byte. So what I'm basically doing is I'm taking position 6 and position 7, and I'm stuffing them into sensor 2's array. So basically, my joystick will replace 6 and 7, which are actually this position and this position, because if you remember, this is actually position 0, and then this is 1, 2, 3, 4, 5. Here's position 6, which it'll probably be like when it's idle, it'll probably be a 0, and then this one will be position 0 in the beginning. So if we want to go back up and look at what we're doing with this character array, so we do have A5 and 5As, the serial the serial identifier. We're going to send it 5 bytes. We're going to be concerned about register 82, which means that's what we're going to be sending data to. 0, 0, and 0, 6 is going to be the specific variable that I want to send it to. And then I'm going to actually send these two numbers into this 0, 0, and 0, 6 variable, which I'll talk about that once we get to the tool. So we're basically doing that, and then we're going to actually send this. We have to do a serial write command because we're sending raw hex code to it. We identify the sensor to send, and then we're going to send it 8 bits. We're not going to put a 7 in there because it's not 0 through 7. We're actually going to, it says how many bits. We're going to send 8 bits, even though it's 0 through 7. There is, I want to put in a couple other things down here, which I can go over a little bit later. Basically, what I'm doing is if the joystick goes over 100, I'm going to assign Z as number 2. And if the joystick is less than 5, I'm going to assign Z as a number 3. So we'll look at what that means in a few moments. So if we look at let's switch over to the tool. And if we look at the tool here, this is the Stone TFT tool that you can get by downloading it at the Stone website, or it comes with the USB that comes with your TFT display. And what I did is, I've got 3 pictures here. I've got picture 1, 2, and 3. And they are a picture of a Porsche 911 Carrera 4S. It's a car that I like a lot. And you notice I wound up, they all look a little bit different. So for example, this first one it's kind of like a dark view of the car, and the license plate is blacked out. This first one here looks like the light is on, and then there's like a 2-digit number here, which is kind of interesting. And then this one in the middle here, I just put some kind of a word here, and we've got the light on the car here. So basically what ends up happening is we start out with, if you upload all of your pictures to this tool, and you'll see in some other videos, there's some ways that you need to format these pictures in order for them to work. Like for example, this is an 800 by 600 picture because I have an 800 by 600 display. If you have an 800 by 480 display, your pictures will need to be 800 by 480, for example. So basically you add all the pictures that you want, and then all of the pictures will have the file name attached to them. And you'll see in the beginning, there's going to be a 0 in front of this one, there's a 2 in front of this one, and there's a 3 in front of this one. That signifies the picture number within the TFT display. So this is picture 0, this is picture 2, and this is picture 3. You'll notice that in picture 0 is the one where I wound up putting this thing right here, which is basically a data variable. So I put a data variable here, I can put a data variable here. So you can put all kinds of data variables all over the place. And if you look at the data variable that I had here, I'm going to click on it once, and I'm going to go over to the right-hand side of the screen. You're going to see that it says variable memory number 0006. And if you remember in our Arduino code, that that string of characters that we're sending to the TFT display, there is a section where it says A5, 5A, and then it says 82. You know, how many bytes? 82. And then at some point it says 0006, and that's the variable memory that we're going to be sending data to. And then the next 2 bytes is actually the data. So that's how the TFT display knows where to put the data that we're gonna send it, and it's 0006. And then one thing I noticed here too is the integer digits. It's defaults to 1. So if you go over here, it's like 1. So you want to make sure that that's at least a 2, or if you got a 3-digit number that you're sending it to, make it a 3. So this is where you put the integer, or at least the variable that you're going to want to send to it. Now, if we go back to the screen, you'll notice, just a refresher here, we got picture 0, we have picture 2, and we have picture 3 here. Let's go back to the Arduino code and see what I'm doing near the end of the process. So if you look at the bottom here, I've got if y is greater than or equal to 100. So that means if my joystick is at the top of the scale, for example, I want z to be number 2. And if you remember, there's something called picture 2 in the TFT tool. I also have picture 0 in the TFT tool. And there's also picture 3 in the TFT tool. So if the y-axis of the joystick is 100 or more, then I want to go to switch to picture 2. If the y-axis is less than or equal to 5, I want to go to picture 3, which is kind of the darked out picture of the Porsche. And then if none of these are true, then I just want to sit on picture 0. So it's going to show picture 0 first, and then if there's some other things that happen, it's going to change the picture. Well, how does it really change the picture? What I do is I essentially take this first array here, and if we break this down, we got 5A, A5 and 5A, which is the serial device name. I'm going to be sending it 4 bytes. I'm going to be sending it to this 80 function, this register of 80, which means switch the picture. There is this 03, which actually I can't remember what that means, but I think this is the picture switch function where there's 80 and 03. These two together switch the picture. And then these 2 digits are going to be what picture I want to switch to. Well, since I only have 3 pictures, the first byte is always going to be 0. You know, if I had like 20 pictures, this first byte would be the first, you know, it'd be like a 2, and then the second would be like a 7, you know, like 27. But I only have 3 pictures, so, and I've got this sending it picture 2 by default. But when we go through here, I have z equals 0, and then sensor 1 position 5 in that array, and don't forget we start at 0, so this is 0, 1, 2, 3, 4, 5. So this is going to be the high byte, which is probably always going to be 0. And then sensor 1 is going to be the low byte of z, which is going to be, it's actually going to be 0 in the beginning, right? So these babies are going to be changed to 00 and 02 because of these statements right here. I'm going to write the whole command for sensor 1. It is only 7 bytes, right? 1, 2, 3, 4, 5, whoops, 6, 7. So I'm going to write 7 bytes to serial 2, and I'm going to send it that array. So that's what's going to happen here. If we then all of a sudden, if our y-axis is over 100, z is going to be number 2, is going to be assigned 2, and then because of these 2 statements, we're going to encode the number 2, which is z, into position 5 and 6 of this sensor 1 array right here. So these two numbers will get changed. This is the page switch function. So it's going to switch the, it's actually called picture switch, I think. So it's going to switch to the different pictures. So that'll be kind of interesting. If we go back to the TFT display screen, or the tool, I should say, and we look at that. So when the joystick is all the way less than 5, right? I think that's what I made it. I want it to be on picture 3. So we've got the picture 3 right there. And it shows that this Porsche is relatively dark. It's kind of like the Porsche is off right now, and we didn't start it yet. But as I move the joystick upward and I start increasing that integer, I think it's y is the integer. As I get above 5, it's going to picture switch to 0, and it's going to start incrementing. Here, let me get rid of these old. These are my demo from just a minute ago. So it's going to increment this, kind of maybe even simulating the speed that I'm going, like a speedometer, for example. And it turns on the license plate light too, if you notice. So as we go higher and higher and higher, at some point, if it gets to 100 or more, it's going to picture switch to picture number 2. And I just put this little funny word in there just to be funny, just to show something. And then I actually got rid of the speedometer in picture 2. So that's how that all works. Again, you can, if you look at picture 0, and we look at this variable here, and look on the right-hand side, variable memory 006. It could be anything. I've seen people use 002, 004, whatever. You just have to be consistent with the variable memory here when you're addressing it in the Arduino. So this is pretty simple stuff. The key is to make sure that you have that (1) on the serial begin statement, so that you don't have to use the ESP32 or the Max 232 chip, so it can interact directly with the TFT device using just straight TTL logic. So we don't have to worry about that. And then if we look back at the Arduino screen here, you'll see that I just oh yeah, I wanted to show you like where you get this serial thing, because that was unclear to me for quite a while. I wasn't sure if I wasn't writing to the right device or what, but I was having some challenges in the beginning, and that was before I figured out this this number 1 here. So let's go back to the Stone tool, and we'll look at that. So if you are in this tool, and I believe you go to, I think it's screen configuration, you will see the serial port parameter configuration. This is where you can change the baud rate, which we have at 115/200. And then here is the A55A. That is where you find the A55A. And I would imagine that if you have a couple of devices on the same serial line for some reason or another, or you're, whatever you're doing, you might need to change these. This is where you would change that. So everything else I've left the same. I haven't really messed around with any of these other options, but that's where you find the serial port parameter. I believe that this is like the serial port identifier of this device, for example. So that's where I found that. Hope this was helpful, and these Stone devices are really pretty cool. I believe the website is stone-hmi.com. It is Stone Technology, and yeah, they've got a lot of information, a lot of tools on there. I want to buy mine from AliExpress, and it didn't take too long to get here, and it was in fantastic shape. I wound up getting the one that is, it's an 8-inch, it's a 800 by 600 resolution. Common resolution is 800 by 480. There's some 1024 by 600s, and there's also some 640 by 480, as well as some of the smaller ones, which are 480 by 272. So there's a lot of cool options out there, and they're really not that expensive. I think I got this one for a little over $100. So hopefully this was helpful, and have fun programming.